Alright, I'm praying to the puzzle gods to give me a nice easy problem that hopefully we can solve nice and fast tonight. Please, no more virtual machine problems. No more 2D grid problems. No more like battle simulation problems. It was so bad. Okay. Map of the local orbits. Orbit looks sort of like this. Use over NA. Use over NA. Oh, jeez. This is gonna be one of those like chained relationship problems. Okay, alright. Alright, so we're gonna use our lines here. What is this? Orbits line. All right. Let's see how that goes. Okay, that looks correct to me. Orbits. Let me just make sure that all these inputs are, yeah, okay, they're all 3 and 3. All right. Okay, so for each orbit, all right, so we actually want to do this the other way around. So first we say, is there something being orbited? So if it's not in there, if it's not orbiting anything, then we do 0. If it is orbiting something, then we do 1 plus rec orbits of the thing that it's orbiting. Right? Does that seem good? Woo! 48. All right. We did it, guys. Okay, now the hard part. Yep, okay. Okay, you're in orbit around K. We have to figure out how to get to another thing. Yeah, this seems hard. Actually, I think this is like a meet in the middle thing. This is actually a lot like a blockchain reorg, which is kind of hilarious. Alright, let's try this. Orbit path of U and orbits. Okay, alright. So now we have U path, and we'll also get the sand path. And then we'll just find the point where they meet, right? Yeah, okay. So actually we're gonna do this the other way around. I think that'll be a little easier. Okay, and now we just do like this, you know, for I equals U path. If U path I equals sand path I. Alright, so then we just have to do I'm guessing that this is going to be off by 1, so we're going to have to do it against the thing. So annoying. Going on here? K to J, J to E, E to D, D to I. So is it just like -2? That'd be pretty dumb, but you know, it could be. Hey, 76. You know, I'll take it. I'll take that for sure. That was good. Feel pretty good about that. You know, we weren't crazy fast, but we did much better than the last 2 days, so I'm happy about that. I got 48th place on the first one, and I got 76 on the second one, so it's a good chunk of stars. How many stars? Yeah, 53 and 25. Not bad, not bad. Where does that take us on the leaderboard? That's the question. 57th. Okay. Still far from the top. I'd much rather be in, you know, the upper 50%. But that's fine. If we can do that every other day or something, then we'll definitely get up there, because there's a lot of people in here who like score really well on one and then just don't get any stars after that. So you can see, like, if we get first place on one day, like one part, that would give us like 100 points, and that would take us all the way from 57th to like 36th place or something. Wow, that's quite a jump there. From 36 to 34, that's like 30 points. No, 23 points. It's interesting. So nice. That only took 13 minutes, so let's go ahead and port that to Zig. I think that won't take long. We'll fire up the old Zig, the Ziggy Stardust. I guess I should make this more robust somehow. I don't know, like, the subtracting 2 seems pretty much like a hack. So I wonder, like, what's the correct way to do that. I think if you did it this way, that would also work, but, like, does that make sense? Maybe. I don't know. Works well enough. I like that I was able to hit upon this recursive approach pretty quickly, and that served me well. Okay. So what are we doing here? We're gonna make a copy of what we already have. just because it has some boilerplate in it. Yeah. So we already have a utility for reading a file, but do we have one for splitting it into lines? Read file lines, yeah, that'll do it. And then we want to split this into its parts and then add all the parts into a hash map. I think I used a hash map on one of these problems, so I think it's actually in my utilities already. Yeah, make map. So what? Var map equals utils.make map. And it's going to be a map of strings to strings, which I wish in Zig you could just say string, but no, it's a const slice of U8 instead. Much like C, I guess. You know, it's like a char star. Okay, so for input lines, we're going to insert into the map, which D3 was the one that I was using the map in. So, okay, so you do map.put. So for each of these, you want to do map.put. I should really have like a split thing in here. There is like this standard library function in Zig for splitting, but it returns like an iterator, which is not really what I want. Yeah, I want this basically. Zep. I'll just call it parts instead of lines. This is nice because now I can just do, you know, return split data on line. That's nice. Hopefully that works. I guess we should test that before we do anything else. All that print line. Utils.split input 0, and we're splitting on this paren, this closing paren. It didn't like that. Something wrong in the utilities? Data? Sure. That's what we want. Okay, it seems correct. So for each line, we're going to split the line. I don't even know like what to call these. I call them XS in the Go program, which is just like a habit from Haskell. X is just an arbitrary thing, and S is plural. So just use XS for like any sort of list, but it's a pretty bad name. Okay, we want to associate 1 with 0. I think I'll just also print these. Oops. Just to make sure that we're doing this right. My utility printline function only prints one thing. It's not the best. It really should be variadic, but it's not. What the? There's just not a lot of slices because the intent is unclear. Oh no. Oh. Consider using standard auto hash.hash or providing your own hash function. Oh, consider string hash map for hash contents. Okay, all right. It's complaining because I'm trying to insert strings into the hash map, but there's multiple ways of hashing strings, I guess, so it won't just do it by default. I have to specify how I want to hash it. That's annoying. I guess that means we gotta look around in the standard library for how to use this string hash map. String hash map. Might not be so bad. I don't know why it can't select this by default. It seems like a pretty easy thing to do. String hash map constitute. And then we have to initialize it, right? I wonder if I could just have my make map like do this for me automatically. I don't know what the return type would be is the problem. So we'll just do this. Is anyone watching? Anyone have questions? No, 3 people are watching. No one has any questions. Oh, Adam's watching. I don't understand why Adam is watching and not solving the problem. Did you already finish, Adam? Better have finished. Yeah, okay. Adam got it. Now we can take a break and watch some Zig coding. Okay, what are we doing? So we have our string hash map. We're gonna see if it will accept this. Okay, great. It looks like it did. Looks like it did that just fine. So we are in business. Now we basically just need to port our like 2 recursive functions over from our Go code. These guys. Yeah. Okay, so it's taking a string and a map. I don't know what the type of this is going to be. Okay, and how do we access things in the map? Yeah, we do if map. I think we could just do if map.contains. But I think what we actually want to do is this. If orbits.getValue, this actually returns like an optional. I just remembered that like sort of the point of this is that I'm like describing some of the properties of Zig as a programming language, which I don't think I've been doing a great job of. But this is kind of a nice feature. The map lookup returns an optional value, and then you have this. It's sort of like the same as the for loop syntax. You put the thing in these pipes, and this branch is only executed if the optional is not null, basically. So here's our case here. And in Zig, everything is an expression, so we can do this, else 0. Yep. I think there might be a more compact way to do that, but whatever. So here we're going to call ourselves recursively, but with the parent and with the same map there. This one though, the orbit path, I feel like that's going to be more of a pain because we have to like append, and appending is nice and easy in Go, but not so nice and easy in Zig. You have to like manually reallocate the memory, I think. It's not fun, not very fun. So that's too bad. But we'll cross that bridge when we get to it. Let's just do part 1 for now. And for that, all we need to do is call rec orbits on. Oh, right, we need to do it on all of them. Okay. Var in size equals 0. Zig is sort of, it's similar to C in that you have to specify the initial value for your variables, and they can be undefined, but you have to say undefined explicitly. Whereas in Go, it's like everything just has an implicit 0 value. In Zig, you have to be explicit, and that's like a, it's an optimization thing. If you declare something as undefined, then it means that the compiler can just reuse whatever memory it has flying around without having to zero it. So usually you'd declare like an array as undefined, because then just gonna immediately like write a bunch of things into the array. So there's no point in like zeroing it first and then overwriting all the zeros with your actual data. So, and I think the compiler will complain if you initialize something as undefined and then try to like use it. I think if I define n as undefined and then I print it, I don't think it'll like that. Okay, all right. it ran it just fine. It did not complain about me using an undefined value, so that's nice. I think if you run in like debug mode, it'll do something that I know other compilers do, which is anything that is specified as undefined, it will fill with a recognizable pattern, like alternating bits, just 0, 1, 0, 1, 0, 1. So then you can sort of see where the undefined things are. Let me see if I can do that. Okay, I don't know how to build a debug release. Debug release safe. Maybe it's release safe, I don't know. Doesn't seem very safe to me if it's just gonna let me do this. Wow, it's taking a while to compile. Maybe it has to like rebuild the whole tool chain because I've never done this before. And it didn't make any difference. Okay. Moving on. We don't want this to be undefined, we want it to be 0. And now we're going to iterate over our map, which I have not done before. Call it orbits. I wonder if we could just range over it like this. Maybe. Rec orbits. Orbits. No, not really that. Okay. So, guess we're just gonna have to look at the standard library to figure out. All right, iterator, subconst iterator. How do I get that? Can I just do that? No member named iterator. You sure? It looks like it is. Oh no, see this equals makes it sort of look like it's defining a variable, but this is a type. In Zig, there's no separate like syntax for declaring a type. You just declare a constant as equal to being an expression that evaluates to a type, which in this case is just a struct. So that's kind of interesting. That probably means that there's a method here that will like return the iterator. Guess I could just search for it. Iterator. Yeah. So it's just a lowercase iterator. The question is, what type does that return actually? What? How does this work again? Maybe you have to use while. Yeah, okay, use while. There's no, it's not like magic syntax. You just have to do it.next, and that returns an optional thing again. So this is just like the if up above. It's just that it's in a loop. Yeah, okay, so this is going to be a KV. And we want what? Do we want the key here, or do we want the value? I think we want the key, right? Yeah. Okay. What's going on here? Error expression value is ignored. Really? Maybe these aren't supposed to have question marks or not semicolons. I don't really understand why it's ignored. Expression value is ignored. Yeah, it doesn't really make much sense to me. What happens if we change it to be a not, you know, if else expression? Hey, okay, you ran. Is that the correct answer? It is. All right, great. I guess I'll come back later and figure out why that if else didn't work. I'll try one thing here real quick. Zig syntax does allow you to do this. It lets you omit the braces if your block just has one expression in it, which I don't really like that, honestly. I prefer to be explicit about it, but okay, apparently that was the problem. So debatable whether that's actually more understandable, but yep. Okay. Anyway, onwards to the next thing. So what are we doing here again? We're recursively generating the paths. Back from each of these guys up to like the root. This is why I was saying it's similar to like a blockchain reorg. Something that I've been working on recently. With the reorg, it's like if you see some other competing chain, and it has more work on it than your current chain, you gotta migrate over to it. But in order to do that, you have to find what's the shared parent between your current chain and this other chain. Like at which point did they diverge? And so it's the same deal where you have to iterate backwards until you find the shared parent. I'm not sure off the top of my head how we do it in Sia, but I think the nice thing there is that each block tells you basically like which height it's supposed to be at. So you can use that as a way of figuring out where the forking point is. Whereas in this case, all we can see are just the names. We don't have any other sort of information about them. I don't know if that's true. Anyway, it doesn't really matter. The algorithm that we're using here works just fine, which is we trace all the way back to the root from both the guys, and then we delete from the front of that as long as they're the same. And so when we get to the point where they're no longer the same, then we know that we've found the point where they diverge, and therefore that's like the shortest path from one to the other. And then there's just some like off by one handling that I haven't thought about too deeply yet. So it's pretty simple. I think this should be pretty straightforward to port. The only tricky part is going to be the reallocating. I might honestly define like an append helper function in my utils, because it seems like something that will be useful. And I'll probably just do it like the extremely naive way, which is like allocate a new slice of capacity, n+1, and then copy everything over, and then copy the new value. If you're being smart about it, like you do it the way Go does it, and you like double the capacity, and the color doesn't really see the capacity, but next time you append, it'll be able to use the excess space that it allocated. It won't have to reallocate and copy everything over every single time you append. But we're just going to do it the stupid way, because it's probably going to be fast enough for our purposes. All right. So what do we got? U-path, sand path. Oh, Santa is for Santa. That just didn't really occur to me. How's our music doing? Need some good beats. What's a good beat? This is a good one. Oh, sorry, Adam. I missed that you were chatting. Yeah, I should probably like set up my screen so that I can actually see this chat window, right? How do I do that? There we go. Zig is the first language I've seen that advertises that they have undefined behavior as a good thing. Yeah, I'm not totally sure about that. I'm surprised that it let me use the undefined value. I really expected that to be caught. I'm not averse to language having undefined behavior as long as it's, the compiler can catch it and warn you about it, unless you're in release super optimized mode. But at least Zig is properly fully specified. Unlike C or C++, just messes of undefined behavior all over the place. Like it's annoying sometimes. Like in Zig, yesterday's problem, I had to do int casting all over the place because Zig won't let you cast a signed value to an unsigned value just really easily. You can't just reassign it. You have to do an explicit cast. And also, for some reason, for signed values, when you do a modulus, you have to use special @mod function instead of just the normal, % symbol. You can only use that with unsigned integers, I guess, because negative values have strange, there's two different ways you could do the modulus if it's negative. you could like round towards 0 or I don't know, something like that. So lots of int casting. I will say, just real quick, like one thing I really do like about Zig is that you can declare integers of arbitrary bit width. So my flags here this is an array of 3 U1s. So, you know, in theory, this is just like 3 bits. In practice, I don't know how this gets compiled. It might actually just expand that out to like, you know, 3 full words because that's fastest. But at any rate, it's nice to be able to express that. And I think it goes all the way up to like U65536 or something like that. And one of the neat uses of this, I forget if it's like a square root or if it's a bit shift. I think it's a bit shift. I'm pretty sure. There's a generic like bit shift function in the standard library, and you give it, you know, just some arbitrary int type. You could give it like a U32, and you shift it to the left by 1, and it will return a different type, a U33. So it'll actually like increase the number of bits in the type based on how many like places you shift it. Yeah, C struct, you can declare like that they're packed, that sort of thing. You can declare bit fields. I've never done that personally. It seems a little hackish, but I mean, obviously it works. People use that all the time for packing flags into, you know, like TCP frames, that sort of thing. So I'm pretty sure Zig is aggressively going after that kind of software. Anyway, let's see about reallocating this thing. So it's going to be the same basic structure, orbit path, but instead of doing 1 plus, we're going to return. Actually, not sure what is the 0 value of a slice in Zig. Is it null? Hey, wait a minute. This is strange. This is returning an expression, but like it's returning the expression that it's returning is a return expression. I don't think that was supposed to be that way. Alrighty. 42. Okay, so then we're gonna do for u path I if they're not equal. So we might not be able to use this on strings. Might have to do a standard.mem.equal or something stupid like that. Alright, it's gonna be .len. Interesting tidbit about Go. Why does Go have len as a built-in function instead of being a built-in method on slices? I mean, they could have done it like this, right? But they didn't. Why is that? And the answer is, if they did, what would happen if you defined an interface like this, then do all slices satisfy that interface? Maybe. So they decided that it just complicated the interface rules to allow that. So that's why there are no built-in methods, only built-in functions. A little bit of trivia there. Okay, so let's just see if it accepts null as being a operator not allowed. Okay, yeah, it says it doesn't like null. But I don't know what the 0 value is for slices. I might actually have to like consult some documentation on that, because otherwise, I don't know. Maybe it's, I don't even know how it, I'm not very good at working with slices in Zig yet. This is terrible, but maybe we can do this. 0. We're gonna alloc a slice of size 0. Is that allowed? That seems like that's allowed. U8. I think that's how you do equality. Okay. I mean, that returned nothing because our paths are both nothing. But alright, so this is going to be, we're going to append the result of the recursive call, parent orbits. Also, I didn't even notice, but I just declared this map as just like a arbitrary type, and it accepted it just fine. It's kind of like a dynamic typing sort of thing. Like, it didn't even blink that I was calling things like get value on this. So I don't totally understand how var works, but maybe the compiler can see at compile time that, like, maybe it can compute the actual type of this, because we only call it in one place and we call it with something of known type. So maybe it just fills it in at compile time, I don't know. But probably best to be explicit about what type that actually is. So probably later I'll go and fill that in. This is what this looks like, right? Oh. Okay, so for the append, this is how you do generic functions in Zig, by the way. You types are expressions, so you call a function, and usually as the first parameter you pass in a type. Automatic type difference doesn't lose speed, but it does add complexity. Yeah, I mean, it's all going to be determined at compile time. This is probably for, like, sort of generic functions where you don't know exactly what the type is, but like you're going to do a switch. You're going to switch on the variable to determine what type it is, like at runtime. So that'd be my guess, is that var is probably so that you could do runtime type switch behavior instead of having to do it at compile time. So I'm going to go ahead and define generic append function, and it's going to take the type, and this is like the element type of these guys. It's the same type as the single element that we're appending, and then this first or second argument, I guess, is going to be a slice of that. And that's usually how this sort of thing is done in Zig. Like down here when we do the equality, the type that we specify is the element type. This isn't, we're not saying this is a slice of U8s. And I'm not totally sure why that is, but I think it makes things easier when you're implementing the function. You'll kind of see it here. Append comp time t type old and new. So if you take the argument as just t instead of like, it's just the element type, then it's easy to write, I want a slice of t's. But I'm not sure if you could do like, I want the element type of t. It'd be more awkward to write that in your function body probably. So yeah. Okay, so we're gonna alloc t, and it's gonna be old len plus 1. And then we're gonna copy. This is very much like the duplicate function that I have right above, so that's just what I'm going off. We're gonna copy the old into the new, and then we'll also say new old.len equals lm, and then we'll just return new. That's pretty straightforward, right? I could test it, but not. I'm gonna test it by running it, and we'll see just how slow that is. Okay, 478. Is that right? That's definitely not right. Okay. Interesting. Not really sure what we're doing differently here. That's causing that. The only thing that comes to mind immediately is that it might be something to do with this. But I'm not sure. Parent. The orbit path looks the same. That looks right. I think we have to debug just by looking at the test output of this. Let's go back and see the test input. And we'll just save this as day 6 test input. Load that up. And then we should print the full path of these guys. got? So the path to U is B, C, D, E, J, K, U. That seems right, although it's missing the comma at the beginning, which is strange. Maybe instead of returning null here, we should be returning O, right? Just a single slice of O. Seems. I don't think it makes a difference because it just means that we aren't including like the very tip, and we know that we're going to be merged by then anyway. Okay. Son is B, C, D, I. So that's correct. I guess we just have to, in our loop here, it's definitely, it's giving us the answer of 10, which is very wrong. So I wonder if this len is not taking this into account for some reason. That wouldn't really make any sense to me, but who knows? Standard.debug. This is how you do string formatting in Zig. It's a lot like Rust. Personally, I prefer the percent directives in Go and C, but whatever. Why did they use the curly braces? Is it because it's like less likely to collide with things than percent? That's like the only justification I can see. Or maybe you can put like arbitrarily long formatting runes in there. Like it could be a whole word instead of just one character. I don't know. Okay, so we're just going to print out both of these. And then we're going to print out whether they're equal. B true. Oh, yeah, okay, so that would that's the bug. Did Adam spot the bug? No. The bug is that our if statement is actually supposed to be a not equals. So, yep, amateur hour. I would have been pretty annoyed if I was trying to get a leaderboard position and I spent like a good 5 minutes tracking down that bug. Now we see, does this work? It should say 4. Great. So this should work on our actual input. Okay. Adam's not scrutinizing my code. Okay. Understandable. $340. Yeah, I think that's right. Yep. Okay. So we finished our solution in Zig, coming in at a nice 43 lines. And pretty clean, I would say. Seems pretty clean to me. Certainly not like any messier than the Go solution. So that's nice. I'm not super happy about having to use a special string hash map. So maybe I'll come back and see if I can make it so that make map selects that. if you try to make a map with strings in it, but not a huge deal. So yeah, I think we're done for the night, unless if anyone has any questions. I'll stick around for another couple minutes, I guess. But we got it. Definitely happier with my leaderboard placement this night, so feels good, man. I'll load up some Tetris. And I'll hang around for another couple minutes in case anyone wants to ask questions about Zig or anything. Ask me about Urbit. I'm probably going to do another Urbit stream tomorrow. Not tomorrow, what am I saying? Next week. I was thinking, actually, I did one Advent of Code problem in Hoon, the Urbit language, and it was just within my abilities. So the other one's definitely out of reach, at least for now, but I was able to do like the really simple problem. So I'm thinking maybe I'll look through the Advent of Code archives, like the previous years, and I'll see if I can find, some of the easier problems, and we could do solutions for those in Hoon, just to give people a bit of a taste of what it's like programming in crazy Martian language. I'm also doing like proper assignments as part of the Hoon school. I'm learning how to Hoon. So I'm planning to stream more of those. But it's pretty basic stuff. Like the last one that I streamed was, what was it? It was like a FizzBuzz problem, basically. It was like, for numbers less than 1,000, count the numbers that are divisible by 3 or 5, something like that. So that was like that was my exercise for the week in Hoon, was just doing that. So pretty basic stuff at this point, but I'm expecting it'll get more sophisticated. I think we're on week 4 or 5 of the course, so things are moving pretty slow. Like the week before that was like, return the third element of a list. Accept the list as input and return the third element. So not rocket surgery. Okay. Seems like no one has any questions, so let's call it a night. Thanks for watching. Hopefully you felt some vicarious sense of accomplishment because I actually got on the leaderboard this time. Later, Adam. Good night. Hopefully see people tomorrow night, because I guess I'm just going to keep doing these every night. Why not? Oh, and I might also do some streaming of just normal Saya development, if people are interested in that sort of thing. I don't know how that will go, but we'll see. That's on the menu. So until later. Night, everyone.